In this video, we will run through an example of how we can import, process, and visualize data using the Tidy workflow. Here is the example dataset. It is from an online survey by Kaggle, and here you see the spreadsheet with each column representing a survey question and each row representing a survey respondent. We can import the dataset using the function read_CSV from the package readr. These double colons tell you that this function is from this specific package. Also, do note that there are two rows of headers. We want to skip one of these rows, and we can do that using this skip argument in this function. Now, what is the difference between read_CSV we use here from the package readr and read.csv that we have been using from base R? Well, read_CSV imports tabular data as tables, which is a special kind of data frame, but it has stricter rules that avoid the hassle and avoids errors that is often associated with conventional data frames. The same methods that apply to these conventional data frames also apply to tables as well. I won't go into the details here, but if you're interested, you can refer to this link in the slides. Let's demonstrate this difference. Let's say we have assigned the data to this variable called survey, and we examine the first few rows of survey using this function head. In the output, you'll notice that it is a table with 6 rows and 395 columns. That's a lot. We see the first few columns here. Notice that with tables, the output shows the data type as well. DBL means double, representing a numeric column, and you have character strings for this column. On the other hand, if you use read.csv from base R and you assign it to a different variable called survey2, you examine the first few rows, you will see an output that's quite basic. It doesn't show the dimensions and it doesn't show the type of data. One key difference you will notice is that you see full stops between the words in these column names when you use read.csv. Compare this with a table, you can see that there are white spaces. Recall from an earlier video that it is best practice not to include white spaces in your column names. If white spaces are included, this would confuse R. And what you will need to do to tell R that this is a column name is to surround the entire column name with backticks. Importing tabular data as a table will preserve the column names. On the other hand, base R will simply replace these white spaces and symbols such as open brackets and close brackets with full stops. Now, analyzing the data with such long column names is not going to be very feasible, and our code will be very difficult to read. If you examine the first few column names, you can already see that the column names include very long sentences with white spaces and special symbols as well. What we can do is to tidy it up a bit with some housekeeping. For example, we can use this function rename from the dplyr package to rename this column representing the duration of time that the survey respondent took to complete this survey to this word duration. So here we take our object survey, we put a pipe, we use the function rename on the survey object, and we want to assign a new column name based on the old column name. Don't forget to surround it with backticks. And we assign it to the same variable or object name, survey. This would overwrite the existing object, and so survey will now have a new column name called duration, replacing the old one. Other than renaming columns, we can also change the values of an existing column. Now that the column name is called duration, we can convert the duration from seconds to minutes by dividing by 60 and reassign it to the same column name. This would overwrite the existing column name. The function that allows us to do this is mutate from the dplyr package. So here, after tidying up the data and overwriting survey, now the duration column is in minutes. Next, we can also wrangle or manipulate data using the filter function from the dplyr package, instead of using operators such as the square brackets in base R. The syntax is quite different. For example, if we want to subset or filter the data only to respondents who took less than 30 minutes to complete the survey, we simply input the object, put the pipe, apply the function filter, and we put in the criteria. We want the duration to be less than 30. This data includes respondents who took more than 24 hours to complete the survey, probably because they left their browser window open. This is how we would code it out, using functions from the tidyverse rather than using base R operations. Now, there are many other functions from the tidyverse, which I will not go through, but here is just another example using functions such as group by, summarize, and arrange from the dplyr package. Let's say we want to tabulate the number of respondents per country. We can take our object survey, so we rename this column to country to simplify the column name, and we want to group the data frame by this column country, and based on this grouping, summarize the number of rows for each of these groups. We count the number of rows using this function n, and we take that count and assign it to a new column name called count. This would drastically reduce the number of rows. So now the number of rows would be essentially the number of countries. Finally, we can arrange the resulting table in a descending order of count. We assign the result of this pipe to a new object called country breakdown, and we can print it. And the output here shows a table with 58 rows of 58 countries and only 2 columns, the country name and the count, so the number of respondents. Finally, let's talk about data visualization using the ggplot2 package. This is a very popular package, and the main function doing the heavy lifting is the ggplot function. The basic idea is that you provide your data. So in this case, we provide the survey object. And the second step would be to assign your data variables to aesthetics. Let's say we want to plot the duration. So this is our variable of interest, and we map it to the aesthetic using this AES or aesthetic function. And finally, in the third step, we assign the graphical primitives. So this really depends on the type of visualization we're going for. In this example, we are going for a histogram. So you'll see bars indicating the frequency of occurrence. Now, it is important to note that ggplot also follows the so-called pipeline approach to code. Recall that we talked about the pipe operator. In ggplot, we use the plus symbol, which means that everything that follows after the plus sign is part of the ggplot function as well. This helps a lot with the readability of the code. And in this example, you see both the pipe operator and the plus sign being used. This is the output of the code that I just showed you. So in the x-axis, we have the duration of time and the count, so the frequency value. Here, I've added an additional line of code with the plus sign. And here's another graphical primitive, a vertical line. The vertical x-intercept for this line, let's say it is the median value for the duration. And so a black line is added to the plot. Because this histogram has a long tail, let's say we add another line of code and we apply a log transformation to the x-axis. This helps us to visualize the distribution a little better. And here is the final figure where I added a few more customizations. For example, I increased the number of bins to 50, so the column width or the bin width would be reduced. I added an argument to change the type of line to a dashed line for the vertical line. You can specify exactly where you would like your axis labels. And finally, the labels for the x and y axis can also be customized. So this is a quick example of how you can customize the ggplot output and change the design according to your liking. From here, we can see that most respondents took about 15 to 20 minutes to complete this survey. All right, before we end off this video, here is a practice exercise for you. Open up your RStudio and load this example data, diamonds, from the ggplot2 package. You can examine this dataset, for example, using the summary function. The first thing to do would be to filter diamonds that are less than $3,000 and with a premium cut. Recall that you can use the tidyverse function from the dplyr package filter, and this would be your expected output. Notice that in this column cut, all the diamonds are of premium cut. Next, you can also plot a histogram of price for all the diamonds, and this would be your expected output. Notice the long tail in price. These diamonds can get really expensive. And finally, plot a scatter diagram of the price, carat, and cut for all diamonds. So the price being the x-axis, the carat being the y-axis, and the cut being visualized as a color gradient. Try working out these 3 examples, and in the next and final video of this section, I will run through the R notebook that covers all the exercises and examples for this entire section. See you there.